Okay, so when it comes to creating a golden image, at the end of the day, you need to have a script that executes and installs everything and configures the operating system the way you want it for your particular application. And in this case here, we're building an EC2 image that starts from Ubuntu LTS, the long-term support release, installs Docker, a handful of other commands, as well as the AWS CLI and the CodeDeploy Agent. So the question becomes, how do you get this script to run and execute on that particular system? And traditionally what I've done is I would build out a complex bash script that would be responsible for calling the AWS CLI to launch an EC2 instance, and then it would pull that instance and wait for it to become available, repeatedly try to SSH into it, and once it was able to, then it would rsync over the install.sh script, execute that, and then if that returned a 0 exit code, then it would exit out of that and then call the AWS CLI once again to bake out that AMI. If you're just starting out and you want to get going as fast as possible, it's not the most efficient way to do it. And instead, you should leverage a tool called Packer. And Packer is built by the HashiCorp organization, and it's an open source project. And I'm just going to read from their website what they describe, like what is Packer and what is the whole point of it. So it's an open source tool for creating identical machine images for multiple platforms from a single source configuration. So that's super beneficial because if you want to have a test environment, maybe that's run locally in a VMware environment on your local network or something like that, and then you publish that up to Amazon EC2, having that same build process working on a variety of different target platforms is super beneficial because you're not having to do any kind of rework that's unique to, say, launching a virtual machine on VMware, and you're not having to do that same kind of duplicate work on AWS and another on Azure or Google Cloud Compute or otherwise. So that is what Packer does. It abstracts away that whole process of launching instances and then being able to execute what they call builders on those particular systems. And so what we do for that, as far as that goes, is there are a variety of different plugins out there that are responsible for providing how you do that. So I'm just going to go into here. So using Amazon EC2, for example, the one that I use is the AMI builder for EBS-backed instances. Now, of course, you could also do instance store or otherwise, but this one is the standard starting point that you want to do for Amazon EC2. So let's dive in and check this out. First, I'm going to talk about our install script because it's there's a couple of gotchas that are worth noting. Set-E, whenever you have a bash script and it's calling multiple commands and you want to make sure that all of them succeed, set-E sets a variable in bash that if any of the subsequent commands inside of this shell script return a non-zero exit code, so that's a unsuccessful exit code, that it will cause this script to exit as well. Set-X, on the other hand, displays the commands that are running, and that's super helpful for debugging. So in the case of this here, where these scripts they can be pretty quick, or it can be kind of a slow process, like if you are compiling binaries or things like that, you want to be able to know exactly where your command exited. So as the commands are running, the standard out displays out those the output or the commands that are ran. So that way you can see, oh, I know curl failed because there was a DNS resolution problem. So that way you'd know, oh, okay, I probably just need to rerun that process in there. The next thing in here, so if you're creating your install script and you're like, okay, cool, I need to run apt-get update, install, and all that. And if you're to do that without this cloud init status wait, then you might run into DNS resolution problems, or it might say, hey, I couldn't get the certificates invalid for a package, or there is no package named JQ or Docker. And you're like, that's really weird. I've tested this in Docker locally. I've tested this on my local machines, and it worked perfectly fine. And that's because the amount of time it takes for Packer to launch the instance and SSH into it is before the network is fully set up on the EC2 instance. And so you might have intermittent or frequent failures without having this blocking operation that actually waits for the operating system to be fully booted up. So right at the top, that's why I'm throwing in this cloud init status wait. And then everything else from there, like I'm just catting the LSB release and uname-a just to confirm what the operating system is in my logs, so I know what's going on in there. And then we're just running an apt-get update. We're searching. In this case here, I just ran a search because I was doing some debugging here, so we can actually get rid of that. And then we install all the packages we want. So I want Docker. I want JQ. That's just a JSON parsing thing. So if you're running commands via AWS CLI, being able to like pipe grep for something or piping that through JQ is super helpful. NetTools for network monitoring stuff. Python 3 pip is needed for AWS CLI. And I believe, I don't remember why I'm installing Ruby full. I know I needed that for some reason. Systat for being able to get some basic logging. wget because we want to be able to download files. And then zipping and unzipping. So the zip package gives us the ability to extract AWS CLI. And then at that point in time, we just need to get this system configured. So we download AWS CLI, and as far as Docker goes, we need to add we need to create the Docker group and then add our Ubuntu user or I should say the Docker user into the Ubuntu group, or vice versa here. So yeah, Ubuntu user into the Docker group. And then we need to have the CodeDeploy agent. Now, if you're running in a different region, you might want to pick from a different CodeDeploy region. Doesn't really matter. From what I recall, it's just bandwidth efficiency. And you download that, we make that script executable, and then we run it. And then this is another little special script I have. So if you're running like VoIP servers or any type of application really that needs to have a direct public IP address that is known to the internet, so maybe you have an application not behind a load balancer, what this script does is if you have a auto-scaling group and it has a tag in there called EIP pool name and you specify that, this script, assuming that the instance has that specified and it has sufficient privileges, it will attempt to get associate that elastic IP to this instance. So that's super helpful for me. And of course, if no pool has been specified there, then it will just exit out and continue doing its thing. So that's what that looks like. And then I have some additional modifications in here for getting Docker logs to send to syslog, and then the syslog information in here to get all that parsed in. So that's what that looks like in here. So we just have our syslog, Docker, and CodeDeploy installation process. So that's what that looks like. And now let's look at what the actual Packer code is. And, with 30 lines of code, it sure is a lot shorter than the work that goes into creating a custom shell script to provision instances on EC2 and get that going. And so in this case here, we run Packer. We tell it, hey, we're going to need this Amazon plugin, and that's what provides this source Amazon EBS provisioner. That's the AMI builder, what they're calling that right here, to run. So if you have any questions for how Packer works, there's a whole lot to it. I'm just trying to provide a 10,000 foot view, but we launched that. There's a few minimum required arguments for the EBS builder. So we say, hey, we're starting from the Amazon Ubuntu 22.04 LTS image. The particular one varies from region to region. So in this case for US West 2, that's the source AMI. If there's a newer version, then go ahead and do that. I picked this from Ubuntu's Cloud Images locator, so I find the EBS HVM image and launch that. And then we need to know what we can SSH in as to run that. And then we just say, hey, run the EBS Ubuntu plugin, and then it runs that. And then our additional provisioner that we're going to run is a shell script that executes install.sh. And so this knows how to copy that file up, and then it executes it. And in order to run this, you would run packer build dot. And if you have a different AWS profile, so let's say you run multiple AWS accounts, then you can do in all caps before you run that, you'd say AWS underscore profile equals, and then your profile name that points to your home directory /.aws/credentials file And that way you can use the appropriate AWS credentials to talk to the right VPC and provision the AMI there. And what you'll notice in here, and I don't have all the logs in here, but it took about 5 minutes to build this, which is reasonable for the type of instance it is. But you can see in here, the set-x is showing you what we're running here, sudo./install auto. So that's where the command, that cat command inside of here. So you can see where it's running all of the commands right here. So ./install, that's this command right here. Our cat command is right here. So you can use this to debug a build process if it breaks along the way. So that's what that looks like at a very high level of how to create the golden image for an EC2 CodeDeploy instance. Now, of course, I'll be providing the link to the GitHub repository where you can review this, copy this, and modify it for your own use case. But this is the fastest way to get your golden image for this type of architecture live in any type of cloud environment. And that's using Packer and then your custom install script in there.